Hey everybody, this is Dave D. Hilster. I am a critical thinker, dissident scientist. I'm here tonight and live taking your questions, talking about things. A lot of interesting things always come out about it. I want to thank everybody who was already online for coming by. I really greatly appreciate it. Keep my subscribers continue to grow. Also really appreciate that. And tonight, one of the things I'm going to be talking about, and I think is going to be it's something that's on my mind, and I think, of course, you always talk about things that really sort of on your mind, and that is dissident infighting. I notice a lot of dissidents online, people who are outside the mainstream, who are, out there, hey, being critical thinkers, trying their own ideas about the universe, coming up with their own models, their own take on things, are often attacking each other, and that's like, folks, calm down. First of all, that's one of the problems of any endeavor. Mainstream does that all the time. There's people who do infighting because they all try to agree on something, but infighting just doesn't help. I don't believe in consensus. I did a video number of years back. It's got several thousand views, and I've had a lot of comments about it. On consensus is not something that is a good thing for science. It's not good for pretty much anything if you want to try to advance any type of endeavor. I know. So look up the Hilster consensus. You'll see that video. Anyways, I still am really just taken aback by watching other channels today and seeing people just go through other people who, some people lump everybody together. The entire world is wrong and I'm right. There are channels like that, and folks, it just looks what it looks like to the outside world is a bunch of people who have their own ideas, and they always claim that we don't know science, we don't know the scientific method, we throw things away that we don't, and we just don't understand things. That's our problem. We try to reinvent everything, and but the infighting is just not good. I think people, it's different to argue about things. It's different to have arguments like at our conferences, our CNPS conference, which people are registering already for. In Washington State, it's going to be in the University of Washington, in Seattle, and we're going to be there between, I believe, June 26th through the 29th, which is a Wednesday through a Saturday. It's always a great time. You really want to come by if you're in that area. It's pretty cheap. We don't charge much, and you get to hang out with some really great thinkers and see and hear and listen to really great papers. But most of all, you're just going to hang out with people, and believe me, everybody there is talking about science and things outside the mainstream, and all kinds of incredible conversations go on during these conferences, and so you don't want to miss that. But when we're at those conferences, we don't spend our time just, we do argue, but we argue the merits or the problems or flaws that we see in other people's work. We're not there saying, you are stupid, you're excuse me, you're all right and you're all wrong. Oh boy, that's kind of a weird slip. You're all right and I'm wrong. I don't think anybody ever says that. I just may have invented a new phrase. You're all right and I'm wrong. Anyways, you're all wrong and I'm right. Although we have people that sort of take that stance, I think we have to, number one, and that's what I try to do on this channel, I could easily rip into someone's theory and say, aha, you have the ultimate particle, there can't be an ultimate particle in theories, and so you're wrong. Why do that when their model is way better than the standard model? Why do we even do that? And I just, it's something that really bugs me, and I think we just have to stop that. Again, I subscribe to these channels, and I see people going. I'm starting to see dissidents talking about dissidents channels a lot more, and they just drag on them. So you know, it's not good. You know, I'm almost thinking about trying to talk to Walt Thornhill and David Talbot, and say, hey, I'd like to come and give a talk about, hey, everybody being very aware that let's stop, you know, criticizing other people who are outside the mainstream. And this is not like, so, well, we band together and we'll be stronger and we'll change the world. No, it's more like this is the way science should be. We should be supporting each other's ideas, even if we don't agree with them. We do that, like I said, we do that a lot in the CMPS. So I just think it's, you know, really not good. And I even know in my subscribers, and I appreciate people putting their comments. I get a lot of comments a lot of times, depending on what I talk about. Really sort of pushes people's buttons. But it, you know, it's one thing to talk about something. It's another thing to sort of get nasty about it. It's another thing to get upset about it. It's another thing to yell about it. It's just not. You know, when anybody comes at me, I always try and be very careful. I'm sorry, guys. It's not that even late here, 9 o'clock, but in the evening. But I make sure I do not spend time wording something in a defensive way, or, you know, the most I'll say is silly you, or something like that, like, hey, that's silly. And I don't, you know, trying to even use words that are not aggressive like that. So let's see, we have 7 people. Thank you very much for showing up. I know I come on board, people come and go depending on where they are in the world. I know some people have been watching even in Europe, and unfortunately this isn't the best time, and sometimes people stay up till 1 o'clock. But how do you rate the importance of Vladimir Ginsburg's work? Oh, good. Look at Tyler Tom. He must be like an old guy from, do I have this book here? Ginsburg. I know Alexander Ginsburg. Yeah, absolutely. He's had actually a new book out, and I'm just trying to find if I have that around here. Hope you can hear me. My voice is pretty loud. Let's see, post-relativity physics. I'm looking. Ginsburg is a person that has, I can look him up. But come on, Dave, I know I've got his book. It may be in another place. I really have to get these things together now that people are asking me about it. I will get back to you on that. Let's see, James Carter. Man, I got a lot of Carter's books. People actually send me books, and you're looking at the back of my head for a long time here. Let's see. I tried to put all my dissident books. They're not all here for sure. I've got some here too. Charles Lucas. I keep pushing them over here, but I don't see Ginsburg's book here. You know what, though? My dad came up to me today, and I've got another one, Perry Spolter. Someone asked me about that, and my dad actually sent me a white paper showing that some of the calculations he isn't in great agreement with. But let me look him up and show you, see how much I can find online here for him. But yes, I do know him. I have read his books. He has his own sort of theory and models, if I remember, of subatomic structure, if I believe that's true. Let's see, I agree, David. I usually find find at least one gem from each person's alternative thesis who has spent serious time. Yeah, that, you know, absolutely. Lost Horizon, aka Debbie. Absolutely. Absolutely. In fact, the crazier the idea, sometimes you get like really amazing gems from them. Let's see if I can get something from that. Yep, Dr. Vladimir B. Ginsburg. Yeah, and there's also another person. He's Russian. That's what I thought. Let me show you his. Maybe I can get it from Wikipedia. I think it's probably going to be the same. Or Wikipedia being our wiki. Sorry about that. Let's go to that. I can go to that live. There we go. So Ginsburg. Oh, what? It's not there? Oh, wow. It's not in here? It didn't translate into our... Okay. Let's go back to here. Well, I can just go back probably here. That's bizarre. There he is. Wow. How did that not make it into our Wikipedia? I did a translation for it, but anyway, translating, meaning I took our database format and put it in there. He's now 83. Oh my gosh. Vortex theory. Oh yeah. Vortex theory. Unification. Toroidal rings. Yes. And he does have books. And I swear to goodness to gracious, I've got these books. Yep, prime element. Got this one around. This is 2000 books. Prime elements of ordinary matter, and dark energy. Unification of. This is the one. I'm pretty sure he sent me the unification of strong gravitational and electric forces. Can I find it there? Ginsburg. Okay. Nope. Gravity is not free. That's my dad's book. Storm and physics. Okay. Mathematical ideal of the architecture. Whoa. Okay. Anyways, like I said, I probably have it somewhere, and I am not finding it. It may be in my dad stole it. My dad comes into my library and picks up books. It doesn't tell me, and then he says, "Oh yeah, I'm going to write about Harry Spolter," but this is one of his later books. But I did get it. You can see he's got quite a few, but it is a complete system. He's very close to Sarge. Boy. There's another guy that I would say he's Stoyan Sarge. Yep, there he is. Both of them have sort of comprehensive sort of theories, models. Stoyan Sarge was born in Bulgaria. He obtained his diploma in electrical engineering. Again, there you go. Electrical engineers. They are the people. They are my favorite engineers by far. Cornell University. Let's see. Soviet Union. Worked in the Eastern Union. One of the most important theoretical works of Karno's is a monologue on basic structures of matter, supergravitation, unified theory. Published first online in 2001. Structural physics, nuclear. Okay. So yeah, he has atomic models. These guys are really independent type of guys. They've sent stuff, I think a couple years ago, Stoyan Sarge, Ginsburg sent into one of our, it was one of our proceedings. Let me see, I've got some here. Maybe 2016 proceedings. Maybe, or the 2015 ones. Let's see. Do I put a... Yes, I did. Sujak Shaw? No, not in this one. So, our proceedings here. But this guy is Stoyan Sarge, and he and Ginsburg, in my opinion, are very similar in the sense of they've worked independently, have a very comprehensive work I haven't looked at as much at it because it's in the subatomic realm and an atomic structure. When my father and I get to that point in our model, I'm going to be looking at these books like crazy. But as Debbie says, yeah, I mean, these people, you can find a gem in all of these people. But he is also somebody who I would recommend sort of taking a look at. Structure, physics, nuclear fusion, atomic models. Okay, so let's see. Remarkable advances in cold fusion experiments have raised hope that a safer and cheaper way. Okay, he's talking about that. Okay. Field propulsion by control of gravity. See, there's interesting. Field propulsion by control of gravity. Where am I looking? I'm looking in our database of natural philosophy, which is not really formatted very well. Look at that. That should be like in divs. I did it in tables at the time because divs weren't that popular. Yeah. My first website I put up was in 1995 in April. Don't tell anybody. That's old. Basic structure of matter, supergravitation, unified theory. 2004. Let's see if there's any of these links. So those two guys, like I said, helical structures. Oh, that's oops. I'd be surprised if some of these links don't work. Here we go. That's his website, helical-structures.org. You can take a look at that. Cosmic lattice concept. Ooh, is he doing a lattice theory? What's a lattice theory? Anybody know? Been watching? Are you science woke? Let's see here. I agree, David. So, what do you think of James Carter's ideas? Yeah, he just sent me a book. He resends his books to me all the time. I mean, he says, "Hey, a non-ether theory, Dave. Take a look at it." Oh, before I forget, I have a great interview I'm going to be doing on Tuesday. You know who with? Alexander Unziger, the guy who wrote the Higgs Fake, who interviews those Nobel Prize guys. He's going to talk to little old me. Yeah, James Carter sent me a book and said, "Hey, Dave, it's not an ether theory," because he's saying, "Oh, I'm talking about ether theories. What are non-ether theories?" And he had this title on top of it about Einstein, which is not a pretty thing he says. You know what I need to do before I go on air? I need to get all my books in a row. I keep pulling them out. I keep getting them. I keep putting them away. And I get lost by them. And now you can't see half of them because I should be. But anyways, helical structures. And I believe, if you go back here and get to Ginsburg, let's see if he has his websites. I don't know if this will work. Some of this database stuff I really need to clean up. Come on. Come on, guys. Darn it. I don't want to spam. Okay, well. Oh, and events. We usually try to catalog. We did for a while. Let's see. Oh, CMPS 2015. Okay. I don't think I have that one. I don't think I got 2015 with me. I think I got 16 and 17. My dad's got 18 because he sends them out. But anyways, I also got that, did the book on, I did the review on the, yeah, definitely worth, this one brought a lot of ire up, but that was definitely a book that I just ordered. I think I got it for like $6. In the future, these are going to be worth a lot of money, actually. I've got a lot of books, but I will not even be coming close to what of, oh, I got this other one too. See, you come in, you're gonna find out. I just got this one. The Galileo of Palomar, Essays in Memory of Halton Arp. So I guess this should be interesting. I'll look through it, and I'm gonna. Most of Halton Arp's work talks about specific things about the cataloging but Essays in Memory of Halton Arp, edited by and Martin Kokas. I know those guys. What's it say on the back here? The Galileo of Palomar presents a collection of essays that memorialized and reviewed the life and achievements of a courageous and controversial astronomer and cosmologist who was greatly admired by the amateurs and professionals curious enough to delve into and understand his technical writings. For the better part of 5 decades, Halton Arp was heavily criticized and in some cases denigrated by colleagues less inclined to uphold the principle that lies in the very heart of science: the continuous interplay between between theory. Between theory and observation. I was looking at the linguistics. They actually split the word theory after the THE. What? And observation. Historical and technical details are intermingled in the essays, the scope of which is not restricted to astronomy and cosmology. This open format is the only way to achieve a modicum of completeness in portraying a contribution to science that is truly voluminous, reflects a wide diversity of discourse and subject matter, and always pursued with the utmost dedication and respect. So that's nice. So I got this book, and I'm going to take a look at it. But cheap too. I mean, it's sad. Shouldn't be cheap. I'll put it there and forget I put it there. Okay, so yeah, what do you think about James Carter's ideas? Well, I've got lots of his books. I was like trying to find them, and every time I was looking, it's like that's all I found is now I'm not continents and sea floors. I'm not finding them. And he sends them to me. Oh, I know where they are. They're up here. James Carter, where are you? 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 Here it is. One of them. Big Bang Physics without metaphysical. So he sent me another one, which is basically got a different title on the front of it. It said something about Einstein, but it's pretty much the same. And he's showing the nuclear stability model. He has a lot. This is interesting to me, quite interesting. And this is his periodic table of his model of it's toroidal. It's more spiral type of model, I guess. But he shows literally every element. Now, what I would say about this is if you're trying to come up with, atomic models with the model, which my father and I have more, it's pretty much a planetary model. Everything is sort of, you have things going around things, and then you have particle flow that flows together. But it's I think the way I look at it is one of the things that, like I said, Debbie said, is I look at it as people spent a lot of time on this. They really did, and they're coming up with something. And first the thing is I always try to do is what are they trying to do on their point of view? For instance, this guy's looking at helium-3, helium-4, helium-8. He's also looking at, I guess they're isotopes is what they call them. You can see. And you can see they're like two, there we go. You can see like they're two concentric sort of toroids, and they have, you know, positions of things. He talks about what those toroids are. I'm not sure. I think he used to, here they are, the cyclone model of nuclear structure. Now this, of course, is featured in this book, which I do keep around, which is a mainstream book, absolutely, Physics on the Fringe by Margaret Wortham. And you can see there he is, James Carter, who literally just sent me a book in less than a month ago, sent me a book. He has his models that he holds on to. He talks about, oh, here we go. So he's talking about these, and you know who else? Who else is into toroidal rings and forming sort of matter and stable in what we would call ether? Yonel Deneau, one of the great scientists who actually, in my opinion, came up with one of the great findings, which is flowing particles, or flowing particles create stuff that looks just like magnetic fields. And there it is again, but this time in color. So Physics on the Fringe chose Carter. He is more of a loner, and I'm not saying that in a bad way. You know, he's almost sort of a, you know, one of those, you know, eccentric smoke rings, circlons, and the alternative theories of everything. And I think he was chosen because he was sort of, she could work with one person. He was sort of by himself and sort of isolated, and so she could concentrate on that one person. They actually showed up the year 2010 when I was in full blast. Actually, my family, was the first time we hosted the MPA at that time. It was in Long Beach, California. She was there. I never met her. She thought about meeting up, but what did my daughter do there? James Carter was there. He was supposed to be at our Vancouver, and he had a time, and I had to have a time for him to talk. But he's sort of, you know, he's not real sociable, so she, I think, chose him because of those things, and his model was really very different and somewhat comprehensive. And I think she also sort of, in her mind, she chose him because he was sort of safe, because it was something that some people say, even the dissident community, that is it less likely that this model is correct? I don't know. I think there's a perception of it. I'm a person to say to everybody, think what you want, folks, but be careful about saying that no model, you know, some model is less likely than others. But I think that's in her mind, that's the way it was. But the way I put it is, I've read about it. I think it's really interesting. It's really worth getting and just to read about it. And I definitely, I think one of the parts he says gravity is caused by the Earth is, for instance, accelerating and growing larger all the time. We don't know it, so we're all growing larger together, and that's the reason gravity exists. So he has a wholly different idea of what gravity is. But he talks about a lot of things. So in my opinion, James Carter, Ginsburg, Stoyan Sarge, they all worked on their own for quite a while. They have pretty comprehensive structures, models that are models of atomic structure. And so is it worth it? I mean, if you're asking me, do I think they're right? That's not a question that I try to answer. You know, it's easy, and that's one of the things I'm talking about today. It's really easy for us to blow it off and say, that's crazy. This guy thinks that gravity is the Earth's expanding real fast. Well, I will dare anybody here to say that it's not. How do you know that? How do you prove it? You can't prove anything anyways. So I think what we really need to do is take a look at everybody's work and say, what are they giving us? totally positively. It's almost like if you were teaching and you had children in your class who are coming up with their ideas. What is your goal? Your goal is to stimulate, is to keep people going, keep people working on stuff. Unless, of course, you have there's some real big objection. But what good is it for me to say, no, James Carter's model has no chance of being correct. Ginsburg, forget it. His model is just no chance. Stoyan, Sarge, you got to be crazy. No, I think we just got to be careful. We have to step back and say, that's the way I look at it. It's like, this is fun as heck. Look at how this guy has spent time to think about this. I mean, this is atomic structure that's 272. He's just, he's going, I don't know, I guess that's what this is. It would be way beyond what the, and look at this. This is just like powers of 2. And, what is that about? Why does this guy have this? He says, it says Big Bang physics without metaphysical assumptions. So that means here's a person who, I guess the standard model physics and Big Bang theories are based on 4 metaphysical assumptions that have never been experimentally verified. So is he against it? Is he for it? You got to read his book, Physics of the Big Bang Without Metaphysical Assumptions. So the way I look at it is super interesting work. Ginsburg, super interesting work. Stoyan, Sarge, super interesting work. Worth you looking at it? Absolutely. Why? Because these people are outside the mainstream, realize we need a new model, and they spent decades, decades of working on these things. I agree with Dave. Finally, there's one jump. I'm going backwards. Here we go. Yes, I talked about it. My brain is wrapped around these ideas. Yes, mass remains the same on any planet, but matter is actually just energy through ether. That's solnation. Mass is just energy. Okay, let's take a look at that phrase, okay? Because I am your science therapist, and many of us would make the same comment. Got to be real careful with our words, folks, okay? But mass, you're saying that matter is actually just energy through ether, immovable 3D triangles. That's fine, because I think immovable 3D triangles are going to be, are you saying that's like a lattice? I'm a little, so here's what I'm saying. You're talking about an ether, then you talk about immovable. That's like, is that a lattice? Because that would be more immovable, because you'd have to have a sort of a whole, and that's totally valid, folks. That is a valid type of argument. If I was teaching a class, which we have a university online, and eventually I want to be able to have, I want to put together a class on that online university about all the theories that are out there. But you have to be careful. You got ether theory. Ether theories have certain, just throwing them together and mixing them up. I'm not saying that I know a whole lot about what your theory, what you're trying to communicate. But first of all, energy is a concept. It isn't real. So to see that matter is energy is one of those concepts that we use to try to translate one type of work to another. And if you really think more of work and just throw away energy, you're going to do a lot better in general. There's a good, if you go to the CMPS, go to John Chappell Society, and on our website, on our YouTube channel, take a look. There's one, Lori Gardee just recently gave a talk, and she talks a little bit about this stuff. So you want to, take a look at that. And this whole idea that we have energy. She talks about, I knew I'd get to it. What's his name? Harry Ricker, who is a really great science writer, who's going to have a lot of articles on our new website. He was mentioning that a lot of times what people do now is it's energy is just, it's being used as this nebulous thing that you can't put your finger on what it is. So people look at it more like work. I can't remember what the equation for that is, but be very careful. Let's see. That's all I'm saying, Sal. So you're saying there remains some in the planet, but matter is actually just energy through ether. You're going to have to be either way more specific and just throw away. If you can throw away energy and still talk about it, then you're going to get closer to what you're talking about. Mass equals higher frequency energy. Are you talking about waves? That's what I would say. Electromagnetic improvement. Well, it doesn't prove anything, remember. I'm going to get you to speak. You know, I'm not criticizing anything you're saying. I'm saying how you're saying it. There's no proof. Electromagnetics does not prove anything. Nothing proves anything. What we have are models, and those models are better or worse than other models in describing the universe. That's what we have. Whereas static magnets are designed to do it without power. It's just molecular frequencies. After all, particles spin around their nucleus. I don't know what to say about all those things because it's sort of a lot of words in the without a context that I would need. And I think if you start getting into what I call a vocabulary salad, where you talk about all the vocabulary and the energy and the waves and there's frequencies, and people will get lost. They're not gonna. You got to give them something to stand on physicality, in my opinion. If you're an ether theory like Jeff Yee or Glenn Borkert or other people who are etherists, they will try to explain exactly what's going on in a physicality. You got to be real careful about throwing and bantering about all the kinds of words and the vocabularies, and then someone comes up to you and asks a simple question. Well, what's a magnetic field physically? What is it? Because it's a force in the universe. I don't believe it's invisible force. What really is it? And of course, we do have models that will answer that question. The Journal of Scientific Exploration has published some dissident science materials, although they are best known for parapsychology. Yeah, we do stay away from that more. We'll check out that journal. Okay, Unsecured interview. That's exciting. Yes, it is. Very exciting. It's exciting that we have. He has agreed. He's been looking at our website, but I'm a little. I hope he's going to be okay with it, because I told him, I said, you don't have to agree with everything that's on there, and of course no one does. Oh, I am so sorry. No one does. I know Lisa's sick. Lisa Normalanch is here. She did send me an email saying she is sick, and she won't be here tonight. But let me go here to the page. Alrighty. I'm going to see if I can get this a little bit bigger and pop this open, because the new websites now adjust to phones. So let me go there now. Woohoo! I got it smaller, but here is our. Okay, this is not the one I want to. But here we go. Editorial staff. This is really great. I'm just giving you an update for those people who come to the live session. Our editorial staff. I'm the editor-in-chief, because someone has to be dumb enough to take way too much work on doing this. I'm not saying. There's no tooting my horn in any way. But there we go. Dr. Alexander Unseger. German Alexander Unseger is a senior editorial staff. Is a physicist, author, and science writer who has made a name for himself taking on particle physics. He is author of the books The Higgs Fake, Bankrupting Physics, and his latest Einstein Lost Keys. He has interviewed some of particle physics biggest stars, and isn't afraid to ask the hard questions. He can often be, this is my favorite part, this is my own writing for him. He often can be found giving lectures in English and Germany, many of which can be watched on their entirety. And then, oh, I didn't put that in there. I need to put in there, many of which he starts out with the phrase, if you know what I'm talking about and you want to leave now, because sometimes the professors will have their classes come and watch his talk, which just says throw out all particle physics since the 1930s. You'll hear people in chairs scraping the floor and people walking out. So he always starts out his lectures that way. For those of you who know why I'm here, what I'm going to talk about, and don't want to listen to it or agree with it, and just don't want to be here, I will now give you the chance to go out in the hallway. That's that. And there's Harry Ricker, really great. He's a great writer, and so we have there in our editors. You can actually see we've got some. Harry's got probably about 30 or 40 articles already written. And Herbert Dingle, Maverick Science very Delusional Particle Fever, when that came out, the Particle Fever, the movie. Really great, really great stuff. But just so happy to have Alexander Unziger on our editorial staff. He always says you're too kind, but no, I mean, any guy that watches, go watch it. I think I have a video on him interviewing David somebody, who is a Nobel Prize winner for supposedly simplifying particle physics from 19 free variables down to 1, he says. And of course, guess what? It's not true. Why? Because it's blah, 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 blah. And he talks and he uses words, but if you sit back and you unravel what he's saying, it solves none of the things that he set out to solve. It's a word salad, and many people, when they're talking, even amongst my subscribers, you got to be real careful. You don't sit and talk word salads without any nutrition, because I am a whole plant-based diet guy because of my health, also for the health of the planet, for the health of the animal, the whole thing. But if I ate just salads, I would die. So when I call things word salads, it's something that gives you no nutrition, very few calories, and I don't eat salad almost ever. I eat beans and pastas and rice and fruits and vegetables and all that kind of stuff. Lots of potatoes. I love potatoes. Alrighty. So be careful, Sal Nation. You don't want to spin a lot of salads, of word salads, okay? Cool. I have lost 2 books as well. I have those 2 books as well. Oh, okay. Lost. I'm saying that for myself. I've got to go. I have another bookcase somewhere, and I am definitely going to stock that, especially before next time, so I can have those books at the ready. One of my I just had actually one of my subscribers to the channel say his channel has changed his life, meaning his changes. I think he's not a native speaker of English. I think he meant that it's really changed his outlook, and that's what my goal is. I didn't know anything about this myself. I mean, a guy walked into my wife's my art gallery, my wife's store, plunked a bunch of papers, a stack of papers about this high, technical papers, and that was Dr. Karazani, and that's how I got all started, because he showed Einstein. I'm like, okay, let me look. All right, out of curiosity, do you ever find these dense and technical books difficult to read if you have brain fog? I recently read a review of Physics on the Fringe by Henry Bauer in the Journal of Scientific Exploration. Okay. Oh, that's interesting. Yeah, I mean, she went on the tour, and I was really critical of her, and rightly so, I think, because when asked on NPR radio, she was asked about our group, the MPA at the time, and she basically said, the guy said, I'm sorry, I'm repeating myself for those who know, but if you're new and haven't heard this story, basically on the NPR interview, I'll see if I can find that sometime. That's definitely worth looking into. But she said, oh no, nothing. I'm 100% certain. I'm sorry. My daughter put a, when she was little, she put a Band-Aid across this guy's face, which is Jim Carter's face. We shouldn't do that, Jim Carter. But she said, and he asked it in a worrying way. He goes, "You think that perhaps somebody in this group will come up with a better model of the universe," or something like that? That's totally paraphrasing. And she goes, "Oh, no, no." I literally says, I'm pretty sure, the word 100% sure that nothing will come out of the group. And that's, of course, if you think about it, if she was a true scientist or if she was a true journalist, either one, true, if either one of those, she would have said, "You never know. You can't tell. You can't." I can't. When someone asks me, is James Carter, is all this right? I don't know. I don't know. And I think we're not going to know until somebody's model comes along and pretty much people say, "Nope, this is a really good model. We can use it. It technically allows us to do new things," and that's what models usually do. Good models will allow us to then tinker with the universe and control things that we couldn't do before. And that's what. But that was a very interesting story. I'm sitting here peeling this off. She does. Oh, I don't know if I ever read the section about? I'm actually in a book. It's like, whoa. Let's see. I don't think I'm in the index though. I wasn't big enough to make the index. I don't think so. Oh, wait a minute, there I am. Oh, I made the index. Look, I'm famous. You can't see it. Who cares? It's like fame means nothing. No, fame means one thing. If I were famous, it would give me power to do great things. And I'm not talking that I would come up with my model and everybody would worship that model. No, it would allow me to do more things. Make movies about this stuff. I've got a musical called Einstein Wrong. It's a fiction, half truth thing I work on. My dad and I could get a really great publisher for our book. I could build the Quadra Escola de Samba, which is a big samba organization here, big building for. Oh, I got lots of stuff I do. Do a movie. I do a whole movie channel with this. I mean, we're doing channels. I haven't done this, but it's going to be on the Science Woke. You know how we spend all this money on Bigfoot and all that stuff? Why aren't we doing like something like this channel does and go around and actually interview people and say, hey, these guys have new models. So I should pitch that to the Discovery Channel. Okay, let me read something that they wrote about me here. 236. I haven't read these stuff in a while. A Reformation of Science? That's what's in. It's called A Reformation of Science. Here we go. I'll read you some of this. In many ways, there has been a better time. There has never been a better time to be a fringe physicist. We're fringe. You know, maybe I should have done that. I would have attracted all these people here. Although insiders remain as unmoved as ever by outsiders' ideas. That's sad. Paradoxes of physical strife have a source of support today that was unimaginable to its predecessors, for they effectively have their own union. Talking about our group. That's really amazing. Their own union. And I don't really know how to be a paradoxers of physical stripe. Journalists trying to be very established by discoverers themselves, meaning, oh, they're self-indulgent. They make their own theories and they discover themselves. I mean, this is really the wording of this thing is really sad. And the Natural Philosophy Alliance was started by John Chappell, which is what our group is, serves as a publicly open forum in which outsiders can publish their ideas without fear of censure. How terrible is that? That's why I call our group the best scientific group on the planet. Because exactly that. Anyone with a theory of physics can join the MPA and present papers at its conference. Almost everybody. Has nothing to do with who you are. But, you know, you can't go in there and talk about baseball. Anyone, okay, with a theory of physics. Yeah, okay, yeah, that's true. Any alternative theorist can post links to his or her own books on the organization's website and have his or her ideas detailed on a dedicated web page. Whatever else they may be, fringe physicists today are demonstrably not alone. Unlike the men who came knocking at De Morgan's door, contemporary paradoxers. Whoa! Contemporary, we call them paradoxers, have a means by which they can comfort and sustain one another. Oh. I shouldn't read this because I'm getting really mad. Because actually the book's pretty good until she goes into this tirade. Oh, by the way, she lurks around. She's on our email list. When I send out email blasts for our group, which we have about 1,000 people on our email list worldwide, guess whose name shows up? Margaret Wortham. So she still watches. So we comfort and sustain each other. Jeez. On the MPA's website, which is worldmpa.org, which is no longer ours, but it's sort of defunct, long story. People split up our there. More than 1,900 dissident physicists are cataloged. We're over 2,000 now. This ever-growing roster is listed in the organization called World Science Database, a vast searchable archive containing an encyclopedic wealth of information about theorists and their ideas. You're welcome, Margaret. You're welcome. The database, okay, called the World Science Database, a vast wealth of information. Clicking on an entry for any individual brings up a web page that contains personal contact information, personal biography, an educational history, an outline of theories, written books, a list of papers presented at NPA events, and remarkably, an abstract of all papers given. You're welcome, Margaret. You didn't read any of them, did you? I'm sure she didn't. Jim Carter's MPA page lists no fewer than 23 conference papers presented between 1994 and 2010. Here also we find a list of all the MPA events Jim has attended, so we can see at a glance that he has been an active member ever since the Alliance's founding year. Not since De Morgan has there been anything like such a catalog, and De Morgan himself would likely have been astounded at the sheer thoroughness with which this data has been compiled. Here it comes. David Scott D. Hilster, founder of the World Science Database, and driving before us behind the MPA website, yep, that was me, has taken it as his mission to establish as near as functionally as possible a complete library of physics outsiders today. You're welcome. Now we have it more in the wiki form. That's why we're trying to switch to. Along with theorists, the World Science Database contains a separate catalog of books these peoples have written. As of April 2011, more than 1,300 are listed. And a dedicated web page for each of the publications that includes a description of the... Thank you. It's just nice of you. A description of the research. For theorists looking to publish a book, the MPA has a source of a cheap, non-printed, on-demand service where... Okay, that's today and age. That's not so big a deal. And 5,500 dissident science papers, each of which has its own web page. It doesn't. Margaret, get with it. It's not a web page. It's a database that will spit out the data in a web page. De Hilster's achievement is all the more impressive because in addition to compiling the vast storehouse of information, he is attempting to bring some order to it. Dissident ideas are classified into major category types, making the World Science Database the first attempt at a Linnean taxonomy of physics outsiders. I didn't know about that. I'm like one of the great. I'm like what are those? The library at whatever they place Alexandria. Dissident's ideas are classified. Okay, some categories are insider terms, except such as relativity, quantum theory, cosmology. Others signal that we are beyond academic norms. Ether, which you spelled, ether. Oh. Sad. Margaret, do more research. You're a journalist. You should know that we talk about ether, A-E-T-H-E-R, and why? Anti-gravity. Pushing gravity. 0-point energy. Cold fusion. Oh my gosh. Which, of course, the military has been working on for the last 10 years. They're still working on it. So I guess the military is working on dissident stuff. Looking at Jim's entry, we find that his theory classified under gravity, nuclear structure, and toroidal ring. Interesting, his ideas are not included in the category of expanding Earth, a designation that is applied to several nearby entries in the database. I was amazed to find that no fewer than 73 theories are in the expanding Earth class. It is indeed one of the MPA's more common themes. I don't know what she's talking about. This is absolutely not true. There are not 73 theories. All the information in the World Science Database is searchable by author, blah, 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 blah. Enable anyone to be interested, like you, of course, Margaret, wandering through the archive of dissidents. One is struck by the strength of humanity's paradoxical powers. What is this paradoxical thing? I got to go back and read that. I mean, the paradoxes are mainstream. That's why this exists. She's a little nuts on that one. I don't agree. I don't think even De Morgan, gently chiding his discoverers, could imagine how enduring these forces would be. What would have made a fact that the toroidal ring theory is now standardized term in the paradoxer's lexicon? I'm sorry. One wonders that the Tate and Thomas would say also what Tate and Thompson might say on seeing their beloved idea diffused into a fog of speculation. Look at the way the words she uses. Using the Hilster software, theorists can input their own descriptions of their ideas. So in place of De Morgan's random perturbations through fringes of science, here we have a collectively produced encyclopedia that enables dissident science to tell us in their own words what exactly they think. The tables have been turned. Instead of insiders' comments being on the outside, the World Science Database gives outsiders analysis of the inside. This is a new budget of paradoxes written by she's just like into, I guess, reading the other people's, I guess, paradoxes is some terms someone came up with in the bubble of the mainstream, which is very small, actually. Wow. It just goes on. Anyways, check it out. I recommend it, absolutely. Even though I feel that she misses out on the journalistic and scientific most important points, which is never say there's proof for anything, never say that something's never going to happen, never say that something from this group isn't going to... I will say the opposite. History shows that someone in our group, or a group like us, will be the next paradigm shift, as they say. Why? Because the paradigm shifts never come from the inside. And the insiders never shift in that paradigm. They cling to whatever was there. They'll cling to their history eraser experiments, the craziness of parallel universes, the craziness of 11 dimensions, 29 dimensions, the craziness of a space-time that no one knows what it is, the craziness of the particle zoos, which they have no idea how quarks even make up a proton. They say it's like nested dolls or something. They have no idea. I mean, all of this stuff. It's crazy. Okay, get back to you. I recently read the... Okay. Carter's the first dissident I've come across to. I agree with him on fields, ethers, and waves. That book could be downloaded for free on his website. Oh, good. Thank you for letting people know. Take a look at it. Absolutely. Exactly, David, so I agree. I think Carter himself is self-taught, by the way. Probably, I would imagine. He has never been to a university other than a library. Einstein was a patent clerk. And that's what makes half of his story so intriguing, because he's like the surfer dude they're trying to turn into the next Einstein. You know what's funny? I don't want to be the next Einstein. I don't think anybody should want to be the next Einstein. Einstein was wrong. Words definitely get in the way and often lead to circular discussions. Yes, I agree. Energy is a concept. Yep, it is. Are you going to upload more old MPA videos? Tyler! Yeah, I got my VHS right up there. My digitizing card right down over here. It's this way. Down there on my tower down there. I should, yeah. I actually have to do some digitizing. I need to just stick them in, get it running, and then let it go while I'm working at my real job. Hey Dave, you watch any of the Jeffrey Weltzkin videos? I didn't. The Journal of Scientific Exploration published a noted essay by Ian McClellan criticizing relativity called Anomalies of the History of Relativity. Yes. I think I do absolutely know Ian McCausland. I can't remember really what he's, I guess, talks about relativity. Yeah, the older group of the MPA was really, actually, the MPA was founded on almost, not exclusively, but pretty much exclusively on relativity and special relativity. That was their main goal at the time. The legendary Unsecker is on your staff. Yeah, yay! Einstein's lost keys, not keys. Lost key. Oh, thank you. Did you read Herbert Dingell's book, Science at the Crossroads? You know, I may have it. I may have read that. But I do. We have this article that's... Actually, you can find this article. It's on our CMPS website. But it is going to be part of the Scientific Woke website. It's getting there, folks. I know. But I keep writing. I just keep writing. Right now, I am writing a lot on the... I'm finishing the article. Let's see if I go to home. Just to give you an example, I'm working. That's why I haven't been doing so many videos, because I have been working. If you go to this, these are the headlines. Finish that one, finish that one, finish that one. This is the one I'm working on. Amazing progress outside the mainstream. So this one I've been literally working on in the last few days. Talking about those people and saying, hey, since I'm like one of those people who know a lot about, not as much as Greg Volk. Well, we're getting close. Oh, this guy is really great. I lost his lecture, and I'm going to kick myself to Kingdom Come. This is, Eric Reiter. He is pretty eccentric, but that's his lab, folks. And he gave a great talk in 2017 at the University of Vancouver about how the double slit experiment and what they're seeing is totally understandable and explainable. So I need to get him. I need to talk with him and apologize immensely for that. I want to have him come into do that lecture again. Now that we go live, directly edited to the internet. But here's this article. So I'm writing article after article at this level, and the reason is because I want people to have, when they come here, they can be science woke and do a lot of what I'm doing here in a very organized, easy way to understand the organization and read about it in a journalistic, easy way that they don't have to be, those. Oh, someone had mentioned, do I get, you get dumbstruck by this kind of book. Yeah, there you go. I will tell you the answer to that, because I am, I've got my degree in mathematics, my Bachelor of Science in Mathematics. I love math. I love math now. I'm not like super crazy mathematician nowadays, and so when I look at these, I do have a gist of what's going on. But what I do is I don't try to overwhelm myself about the equations themselves. I get an idea of what they're saying. For instance, with the equations with Dr. Lucas, I know very well he's combining different types of forces, what forces he does. So I read the text understand what he's doing. I don't look a whole lot at the mathematics, although I will take spot looks at it here and there. So I don't overwhelm myself. I don't allow that to happen. So when I first get a book, I usually go through the beginning. I try to read the big picture first to give myself a scaffolding to hang stuff. Then I start flipping through it, and I usually go faster and faster through the book, because once I have that scaffolding, I can sort of hang things from it. And if I know I could spend 3 weeks on something and I don't have the time, I usually skip past that by skimming it, looking at it, getting the gist of it, and then, you know, going on. Many times if I do have a question, I'll go back and then I'll try to read that and try to get more of an answer. And even sometimes, in the worst case, I'll even email or talk with the person who wrote it. So, all right, Lost Key. Did Herbert Dingle's? Yeah, I haven't read that one. Probably vegetarian here too. Oh, nice, Debbie. Yay! I'm a whole plant-based. Don't eat oil, Debbie. Oil gives you sludge blood. Oil is 100% fat. Those people who are vegetarians. And people who are vegetarians who still eat oil, guess what? They have the same heart problems as other people. So that's just, that's for another channel, not here. 100% sure. Okay. Einstein's Lost Key is a fascinating book. He connects Mach's principle, Dirac's large number hypothesis, and Einstein's much more sensible original theory where light slows down in gravity well. Yep. Don't believe the gravity well one, but, well, it depends on your model. If you have a model of the universe, like we do, my dad and I, we can look at how the model says it's there, but it's nothing like Einstein, what we call space-time and space-time bending gravity bending light. It's not, according to our model, it happens a different way. But again, that's just our model of the universe. I mean, it's right or wrong, but no, it's a great book. I've got it right here. I know I do. I just saw it. Oh, come on, Dave. No. It's amazing. I just saw it, though. That's my book. That's Rational Stuff. Einstein's Lost Keys. Lost Key. I think I put it back. Model of the planet. Nope. I am crazy. I'm absolutely. Oh, did I turn it around here? I did. I had to turn it around. Einstein, Lost Key. Absolutely a great read. I love the book. In fact, I'm going to be talking to him about that on Tuesday. Big Bang without expansion. So this is very interesting. I think absolutely worth a read. Look at my piling books up everywhere again. See, it's like discombobulated person. A very simple explanation of galactic redshift without expansion is proposed. It's just the light spreading out, not the matter. Again, depends on your model. What's light? Like I said, light can't be a photon. One particle cannot transmit a frequency. We've tried. Light is actually going to be multi-particles, and now you're either going to make a particle model where they all come together in waves at the same speed, or you're going to have them all sort of in a soup, like the air, and the waves are waves through the ether. I have read the Higgs fake and bankrupting files, but not Einstein's Key. I should buy it. Yep, absolutely. Dave, do you have constructing quarks? Oh, that one is Alexander Unsker's one favorite book. No, I don't. I got to get that one too. You're right. Absolutely, Steve Beck. Thank you much. I believe that's not a very pretty picture. Is that right, Steve? If you're still here, I see that's back about 10 minutes ago. But if you're still here, isn't that true that constructing quarks is actually a criticism of the particle model. Recommend looking to this website. An ex-physicist that knows very well the sorry state of big science. He worked on it. Okay. How do you explain light as a particle increasing the speed while exiting certain mediums such as glass? Oh, that's easy. In our particle model, we have a great explanation for that. Let's see. Do I have my... Here we go. It's the latest version. Right there is our explanation. What happens is, in actuality, that light within glass goes like this. It does not go in a straight line. And because it doesn't go in a straight line, it slows down. So it's not slowing down. It's going at the speed of c. It just doesn't go in a straight line anymore. And what makes glass or transparent molecular structure is that particles that go through it are guided in that same, they'll stay. So you can imagine, here's the way I look at our particle model. It's pretty easy. If you have everyone has a gut feeling for the way gravity works. So it's just gravity at a different level. It's not the same gravity, it's different level. Basically, so what happens is when particles are shot through, just imagine that you set up suns in the universe here, in the galaxy, in a way that you would make that no matter where you sort of send as long as you don't collide, as long as you send stuff, it's going to sort of guide it through and pretty much stay in that same direction. It's just that what's going to happen is it's not going to go in a straight path. It's going to, depending on if you have more and more nucleons, if you had more suns, well, those particles that are going through it are going to be more deviated. So the more gravitational fields you have, the more deviated they're going to be. So that's our particle model. That's just one model. Could be wrong, could be all wrong. This could be, you know, my dad and I could be on a totally let's see. Light always travels at the same speed. Okay, interesting. Okay, maybe he was talking about that. Or am I going to look at his website? Okay, whose website is that? Alrighty, Andrew Pickerington, excellent book. Okay, so let me look up, just for curiosity. Oh, is it constructing quarks? Is that? Yeah, constructing quarks. For those of you who don't know much about quarks, they were invented. In fact, my contention in one of the articles in Science Woke, which is one of the first articles I wrote, was that model crisis really started when with Einstein, who started this terrible and dangerous precedence of saying that the universe has these types of laws and that everything should follow these laws. And that's why we got the neutrino. It was invented because he said it should exist because we say this. Quarks were invented. Oh, we have particles, we have atomic atoms. So we went to 100 some atoms, and we deconstructed the atoms down to three things: protons, neutrons, and electrons. This is their model, this mainstream model. And then then everything's made out of quarks. But of course, quarks, there were 3, then there were 6, then there were 9, then it went back to 6. And then I have the contention is, if you have a system and you call everything a quark, but they have all these different properties, this is just a made-up thing. There's nothing that makes sense about that at all. Why would you have, and the properties are just arbitrary attributes to arbitrary packages. That's what, of course, not mine, that's the Higgs fake. Deconstructing, okay, constructing quarks. What does it say? Oh, show the browser. I'm wondering if I can make this look, what's this say? Save to pocket, I don't know. Trying to see if I can make this, yeah. Website isn't that great, so to look at it, widely regarded as the classic in this field, constructing quarks recounts the history of the post-war conceptual development of elementary particles, inviting a reappraisal of the status of scientific knowledge. Andrew Pickering suggests that scientists are not mere passive observers and reporters of nature. Rather, they are social beings as well as constructors of natural phenomena who engage both experimental and theoretical practice. Okay, someone asked me to read this, to talk about this. I thought this was like a sort of making fun of quarks. I know that in the Higgs fake he talks about something about a quarks, but I don't know. Anyways, okay, we're at 1 hour and 15 minutes. Was my comment deleted? Pickering is a sociologist of science. I wanted that book for some time. Okay, cool. Okay, yeah, I don't know. Do you have any, Tyler, Tom, did you read that book already? Can you tell me sort of what that's about? Why do wavelengths decrease in mediums? You got to have a model. The answer to you, Lambda, the answer is get yourself a model. Look at what that model say. Oh, this model looks like a model that I sort of makes sense to me. I think I like this model. And then go find out. That's our problem. Most people do not even look at that. Most people are in models are talking about energy and these things, and they're going this and they're doing these calculations. But then you ask them the basic question. That's why my dad and I are working on our model. Not because we are telling everybody we're right. We're just tired of just the people saying, well, it's not, this is the way it should happen, but we don't know what it is. In our model, we know everything what it is. We can tell you why it slows down. I can tell you why color exists. I can tell you exactly, because everything, color, even the color we perceive, for instance, color is basically the pattern of nucleons of any atomic structures, any molecular structures, atoms put together. So when you see a color, the waves coming at it bounce off of that, off the nucleons, come back to our eyes, and basically, the same way with light and how it travels through mediums. Why, for instance, from what we can see, I don't see any other model telling you how dispersion works. What is dispersion? Well, here's a prism. If you put a light beam, white light beam on one side, it will refract. It will disperse into a rainbow. Why? Why does white light do that? Well, we have a physical explanation where you need no math to understand it. All you have to do is have an intuition of the way gravity works, and gravity at a lower level. I keep saying that, but book will come out. And so we have an explanation for it. I haven't seen explanations for it. I'm not here to say that we're right, but I'm here to say that no one asks those questions. No one asks people those. How does that happen? Well, quantum chromodynamics, physicists hate that book. Okay. I would say quarks, in a sense, do exist. The quarks of quantum chromodynamics and quantum are suspect. Quarks are positive and negative charged particles inside proton or neutron. Okay, Steve. Here's what I say about that. Go look up these 3 words: dissident, science, charge. Look them up. Charge is like this. I'm going to probably get myself into trouble trying to do this, but I'm going to do it anyways. Here we go. Oh, probably not work, but I will try. It won't work. All right, just imagine. Here you go. To Apple. This has a positive on it. This one here has a positive on it. Just imagine that. In fact, I'll do it this way. Oh, look at this. We'll call this a positive. All right? That's positive. This we're going to call is a negative. Now, positive and negatives attract, right? And then you're saying that quarks probably do exist because there's positive and negative charge particles. These come together, right? What's charge? I dropped them because I get just tired of that question. Not mad at you. Not many, but numerous models, including ours, have no charge. There's no charge. Why is it that I dropped it and I can't find it again? I'll use another one. Man, it's amazing. I am like the discombobulated. Where did it go? Got another one. Why is it these things come together? Just because you call something a charge. For those again who knows the answer again, I keep asking the question. Science woke people, who came up with positive negative? Anybody? Benjamin Franklin. Benjamin Franklin. Give that guy a charuto, which of course is even Portuguese. Charuto is cigar. So, folks, charge is an arbitrary attribute. It is not a fundamental thing. Why? Because in my dad and I's model, the reason an electron, I'll just use colloquial terms, electron goes around a positron, is because there are little other particles smaller than the gravity particles that we have at our level. G1 particles keep this pushes this down. What pushes a light to refract, to disperse into rainbows? What pushes electrons and keeps them in orbit? G2 particles in random directions. It's the shadowing effect. So what makes something, keep something in orbit, has to be a force caused by mass. There's no magical thing called charge. Okay? So I'm here to tell you, and here's the rule. Okay? Let's say no one agrees with me. My father and I are by ourselves, which isn't true, but let's say that. What would somebody who is an independent person who doesn't have any skin in the game, let's say you think there are quarks and they have charge, okay? Positive, negative. That's what you say. Okay. So I'm looking at the models, and they're going to take a look at, okay, we're going to make a rule. Simpler model wins, right? That's what Alexander Unstriker says. If you have a model that's simpler, that describes the same thing, your model's more efficient. It's better. It's called Occam's razor. So here's the model. Here's the model with quarks with charge, positive and negative. And here's this other model that says we don't need those. All we have is something that keeps this going around, is a bunch of forces, things that hit it, no charge, they're just hitting. It's all kinetic energy. That's all. The entire universe is made of kinetic energy. And the reason this goes around is not because it's positive or negative. It's because there's that type of force. We just arbitrarily say that. And they're going to say, okay, so I've got one that says, hey, it's just going around because of one thing. I don't need to put a positive or negative. It's just gravity. Oh, it's like a gravity force. Okay. Then I have this other one, positive and negative, and they're going to say, okay, what does that mean? What is that attraction? Is it magic? What is it? And you go, I don't know. We don't know yet. Who do you think will win? So I'm not here. I am not ragging on you. I am not saying you're right or wrong. Could the idea that charge is some fundamental thing of the universe? I can't believe that anymore. I can't get myself to say that charge is some magical thing. That when I write a plus on this and a minus on this, they attract. When I can have a model where a person on the street saying, I want to know how is an electron, what is positive, negative? I said, no, there's no positive, negative. What happens is it's gravity at another level. It's a different level of gravity. It's a gravity that we have a level down, and that's what keeps us. What keeps gravity going? Oh, it's a bunch of particles going in all directions, and when they get close together, there's less pressure here. So the particles hit this, and there's less particles hitting on this side. So if there's more particles in this, guess what? They come together. people go, oh, I get that. Oh, I put the positive and the negative. They're going to go, well, what does that mean? So, uh-oh. Debbie, you don't give me charge. There has to be a physical explanation for what generates a perception of opposing charge. Yay! Debbie, I mean, she's a plant-eating, no charge type of person. And I'm losing everybody else. Like, oh, but people's still around. Anyways, guys, there's no pleasure in me saying these things. There's no pleasure in actually doing this channel. I mean, well, I guess there is, but it's sort of like getting people to think about these things, all these things that people think that are there and that we assume, and we use blah 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 in the words, and they come out and positives and negatives and strangeness and upness and downness and colors and Higgs boson and the whole thing, the Big Bang and space-time, all this stuff. I guess it's great to see people whose eyes are open. I guess that's why I'm doing it. But it's sad that I have to do this. One of the really saddest parts is that we don't have, you know, why is it that I had to found a university? I mean, what's the heck is that? That doesn't even open its doors yet. Here it is. University.naturalphilosophy.org. The Chappelle University, degrees in natural philosophy, teaching scientific minds to become critical thinkers. Why isn't it I can't go to any university on the planet and say, I want to write my thesis on how the Big Bang is wrong? And I mean, the Big Bang is not a good model, and here are the reasons why. Here's the observations. Yeah, I want to do my thesis. We have so many great theses for PhDs. Ray Gallucci, I think he's a doctor. Dr. Ray Gallucci in our group. He's an engineer, I think. He had a seminal paper this last year at our conference saying that the distribution of the galaxies, he looked at it. He's not even an astronomer. He just looked at them, did the calculations, and he says the distribution shows there's no Big Bang. They are just basically spread out sort of randomly. They are just sort of like, you know, around, sort of like a gas of stuff in there all around. There is no indication of a Big Bang just by looking at the distribution and taking into account the time light takes to get to us. That's a PhD. That should win a Nobel Prize. Well, it shouldn't win a Nobel Prize because proving theories wrong shouldn't be a Nobel Prize. It should be advancing science. Why do I have to do this? And we're going to put stuff in there. It takes years. You know, I build stuff. Hopefully we'll get, like, oh, I do have to read something to you guys. This is way too blown out of proportion, but I do appreciate the thought. Let me see here if I can find this. Somebody wrote something very nice on my Dissident Facebook page, and it was very kind, and it made you feel good because you changed somebody's outlook. But it was a little grandiose, but hey, that's all right. But it was like, oh, it sort of made my day. Let's see if it's here. I'm looking. Oh, it's from this guy here. Gives me 5 stars. Oh yeah, he said let me see here. I don't want to show you until I get it. I can't remember. I think you put it maybe in the discussion or write a post and I have to prove it or something. Maybe I'll read it from my phone. But this is really great. Let me show you this part. Here's a guy, Frank Farok, and he purchase these books. He says, just received them today. Infinite Universe Theory. Everybody needs to read this. Everybody. I'm making a progressive website, and I'm going to put these books also on my Dissident website. There's got to be books. This is more for people who need to know about how our numbering system isn't good, that our real number system isn't that good, and absolute space, absolute time. So he's like into the mathematics, but this book, and people who like mathematics, those are really great books. Pretty heady, really heady. I'm a mathematician, so I like them, but that definitely, but it's good to see. And he actually wrote something way too nice, nice about it. Let's see if I can find that. Man, I can never, there's so many things where you get messages and you get messages from people and you don't know whether or not they're from Messenger, from Facebook, from a message on Facebook, or they're on your page. Let's see. Okay, let's see if I can find this. Oh, he's from Morocco. Hey, Farouk, if you're there, thank you so much for writing such a nice thing about this. And I'm talking about it, everybody, and I'm not being able to... Anyways, he lives in Casablanca. Oh, here it is. Folks, this is a little exaggerated, so I'm not... please. But it's nice to hear something nice once in a while. It says, the Dissident Science channel is changing my life. I am not flattering when I say that this channel deserves not millions, but billions of subscribers and followers. It's good. I'm not laughing at this at all. If you have doubts about what is taught in schools regarding maths and physics, this is the right place for you. Very nice. But I don't know why. I think I have a plan to get more and more people sort of toward this, because in reality, if you read the Higgs fake, which I think is on my other, is not here, but the Higgs fake has it in there, and he says it, and that is physicists in general are not buying what particle physics and theoretical physics is doing. They're not buying the quantum mechanics stuff. They're not buying the particle physics stuff. They're not buying the Big Bang stuff. They're not buying all this extra dimension stuff. So in reality, engineers think the same way, in my opinion. So I really believe that 99.9% of scientists and engineers are not buying all this theoretical mumbo jumbo. I think they're like, wake me up when you got something real. And that's why I think the particle model, or the ether models, or the lattice models, or even some of the equation models, like Dr. Lucas, they're going to be much more interesting to these people. And I think once something cracks open, and then something like this channel will help people get to that point. That's why I'm hoping that Science Woke will do that, because I think it's got a really good message. It's really done in a good way. And I think we're gonna hit on a lot of stuff, because we're talking it in colloquial terms. Our articles are meant for people who like science. They don't have to read and worry about equations too much, that kind of thing. But eventually, I think something like this can be in the millions for sure. Let's see. Charge is one of the main features of electromagnetism. How can charge not exist? It's like a source and sink. Electrodynamics assumes hydrodynamics and aerodynamics for this reason. Yeah, aerodynamics doesn't have charge. There you go. Aerodynamics, in fact, a plane flying, it isn't even the Bernoulli effect, believe it or not. It's just plain old force going through it. If you put your hand in water and you turn it up just a little bit, like a plane wing, and it's not the shape of it, it's the angle at which it's attacked. When you do that, your hand goes up. There's no pressure difference there. It's that what's happening is things are hitting it and causing it to go up. So anyways, aerodynamics has no charge. The answer to your question, Steve, charge is one of those main features of electromagnetism. Yes. How can charge not exist? Easy. We have particles that push things. The reason magnets attract is because particles flow around magnets. That magnetic field is not nothing, it's something. They're particles. Oh, you can't see them. Of course, you can't see the air right now. You're seeing me. Where's the air? So it's the same thing. So you have particles going around. Both a lot of more and more ether models are also looking at the flow of the ether. And we have particles. And the flows, when they go together, like this, causes them to be stable, and they get pushed together by gravity at the second level, and that's what pushes them together. It's not charge. It's not charge. In fact, go see Lionel Deneu's underwater experiments. That will show you a model of electromagnetism or magnetism without charge, and they act just like magnets. It's shocking. It's one of the great, when I saw that, it was one of the great aha moments of my life scientifically when I saw that in 2008. So that's the answer. There are models that do it without it. So it's like, how can you explain, you know, sound, radio waves going through the air? I mean, it's magic. No, someone then came along and gave a model for it. So, no, we have models that don't need it. Lionel Deneu shows that magnetism can be easily described as flowing particles. And when they go against each other, like this, bash, bash. They bash against each other, cause chaos in those things. That's why when you see magnets, they sort of push each other away. It's more chaotic in the push away, if you ever noticed, if you ever played with magnets. Whereas when they come together, boy, they come together in a very much more controlled manner. The real number system basically assumes that infinite density, at least information in finite space, is possible. A real number system. Well, I would disagree. That's Mayor Calandro. Mayor Scalandro. I would say no. The real number system basically assumes that infinite density. Well, it's not infinite density. It's an infinite number of points. In mathematics, there's nothing physical. So I'm not sure when you say density, then all of a sudden I get mixed up with what you're trying to say. Mathematically, there's an infinite amount of points there. In fact, if you read infinity, the infinite universe theory and infinity in Borkert, you're going to understand that inside this, there's all kinds of things. You know, it's infinitely going down and down and down. So this is like universes and universe and universe. The great thing about that idea is they're not parallel. They actually have their specific space. It's just like we are living in our world on this planet, and we could be an electron on something else that makes an atom of something else that's a chair somewhere. But it's all got its space. So just be careful with the words there. You went from mathematics density, and that's an electrical engineer would disagree with this. My dad's an electrical engineer. He absolutely agrees that charge is a completely arbitrary thing. It's something that we put a plus and a minus with. So yes, most people, charge is a real hard one. I didn't think that charge would be something that people's eyes would be wide open and say, oh, you're right, Dave, that makes sense. Because here's the problem again. The people, if you're clinging to charge, what's happening with clinging to charge is that you are clinging to the idea that you have to say, Dave, where's your book, Dave? Where's your book? Oh, here it is. Well, here's one of the versions. I've got so many versions. Okay, Dave. You say you have a model that shows you don't need charge, and you can describe the universe exactly without it. So charge exists, your model's wrong. So you have to say to yourself, okay, our model's completely wrong. It's impossible. Because if you say charge is needed, our model shows it's not, and that we can easily describe it actually pretty simply. Again, if you have the thing of it's gravity, you know, literally electrons going around this, not because of the same gravitational force as one level down. It's a smaller particle that's just like in the world, just like you have. We have particles for light, if you believe that, particles for gravity, if you believe that, but the particles for gravity at our level are really big, and those particles themselves that make up light or whatever will bend around something like in a prism because of what? Gravitational forces of a G1 level down. You can gravity all the way up and all the way down. That's why I have G1, G2, G3, but you have to throw out my book. Gotta be careful. I mean, it could be worth something someday. It could be worth nothing at all. But so that's what you're saying. You gotta understand that. When it's just like saying, well, there's one guy who's a subscriber who wants to talk to me because he's going to do his PhD thesis in general relativity. And I'm going to say to him, okay, how do you explain to the NASA scientist who worked 30 some years at NASA or whatever, some decades at NASA, who says stars outside of the corona of suns is not being bent, whereas general relativity, because of the star has gravity, it should be being bent, but we don't see that. We only see bending within coronas, just like we only see bending of light, for instance, of light in water, because at that point it goes slower. And that's why you see the stick, when you stick a stick in, it bends, looks like the stick is bending, looks like everything's closer when you look through water. Things that are further away look closer. All of that stuff happens. So how does the guy who's going to explain to me general relativity explain that where it's supposed to be seen, it isn't? And every time they say we do show that light is gravity is bending light, we say no, what you're seeing is coronas bending light. Now anybody can get that. A person off the street who likes science can get that. And they're going to turn to this guy who says there's general relativity. Yeah, let's just take the star that isn't bending. What do you say about that? And they don't say anything. You get silence. Just like GPS. Ron Hatch, who is a GPS scientist, good friend of mine, the first investor in my film Einstein Wrong, EinsteinWrong.com, go see it. And he says he has over 30 patents in GPS. He retired because he was a wealthy man. He actually started a company, was bought out, and had enough money to live the rest of his life. They lured him back with a really great salary. So besides being wealthy, he has a really great salary. And what does he say about special relativity in GPS? It's supposed to be tell you, or general relativity. He says GPS shows the flaws in relativity. It doesn't support it. So people who say that is okay, people that say that there's charge, you got to explain why do they exist. There are models that are simpler and they don't need charge, and they explain the exact same thing without a magical property called charge. Why? You have to explain it. You have to deal with that. Someone's going to come up to you and say, okay, well, yeah, explain that then. You say there's charge, this guy says he doesn't need it, and he explained it to me and I get it. I'm going to this guy. I can't make you make that leap, but those are the logical arguments in a debate. If you were to stand on stage and you would be on one place, and again, I'm not mad at you. I'm not saying you're stupid in any way. Obviously, you're a very bright person. You're here discussing these things. You're open-minded. You have to understand, if you're standing on stage and I'm standing on stage, and I show you a model that you don't need charge, and it's really simple, it's even simpler than the model with charge, and then you have one, and the debate person's going to say, okay, what are the rules we have as judges? Well, simpler is better. That's, in general, pretty much anybody in science who's going to say that kind of thing. What do you stand on? I do it because that's what we learned. That's a system. Electrical engineers, my dad's electrical engineer for 35, 40 years. A great one, actually, very good one. He ended up always being in research, solving problems that no one else could solve. And he says charge is an arbitrary thing. It's a system we came up with. You just amplified the task of explaining how charge works by manyfold instead of asking what causes a positron to attract to an electron. Now you have to explain what causes several particles to smack into one side of an electron and push it towards the positron and vice versa. Well, the way we explain it's pretty simple. Particles can do only one thing, hit other particles. And that's all they can do. There can't be anything else. Particles can orbit other particles, but that's caused by hits of smaller things, smaller particles, again. And that's why we believe in the infinity of Borkert, meaning you never have an ultimate particle. Because if this is the ultimate particle, that everything in the universe is made from this, the only way I can have any theory, and this is just natural philosophy, this is just philosophy, the only way as a system that this thing could create an entire universe, and that's one of the things, the ultimate particle. That's what a quark was. The quark was to try to find the ultimate particle. The Higgs boson, all these things. To get this to be the ultimate particle, the only way this is going to happen is if this ultimate particle, I imbue it magical powers. It's got to have charge. One has to have positive, one has to have negative. It's got to have strangeness, upness, downness. That's what quarks have to have. There's no way that just particles with no types of things other than hitting other particles, you would just get a bunch of like gaseous motion, Brownian motion. That's all you'd have. It's just like the air here. All the atoms are just hitting each other and staying around. They're not organizing. Well, that's just okay. Imagine sand blowing around. Sand just in space. There's going to be hitting it. It'll be there. How do they organize themselves into this complex world? Well, the infinity says this will move and this will curve because there's something below it making it curve. You can't have it curve because of a magical power. You can't do that. So the reason infinity is a better example of the way the universe would work is that every part is made of other small parts, and everything that we have here helps things bigger above us happen. And that galaxies are not the biggest structures. There are going to be other structures. Our galaxies all form probably something, not even a cluster. You know, who knows what it is, but it gets bigger and bigger and bigger and bigger. That's uncomfortable, but it's way more uncomfortable for me to imagine a magical particle at the bottom of the universe doing self-organizing into the entire universe. So, how do we share ideas with you? With who? Somebody you're talking with, I'm not sure, Lambda. If that's with me, you can send me an email. Anybody can send me an email and I'll be happy to talk with it. Oh, or you can join our organization, go to the forums and talk with people there. I think a lot of people are afraid sometimes of going to forums or going to talks or going to conferences because it comes down to one universal theory. That you may be wrong. That your idea may be laughed at. That your idea, we don't laugh at ideas at our conference. I've learned to be very careful because something you think is super crazy, when you start to think about it, doesn't look so crazy anymore. So we in the CMPS absolutely, you know, there are people with theories I do not agree with. People who think there's an ultimate particle I don't agree with. But we still listen to each other, and like Debbie says, you pick out nuggets for yourself of things that these people spend a lot of time on, and you're going to find something you like. It is not a plus or minus charge that can be cannot be perceived. The question is, what causes the property of charge? Wow. I'm going to have to steal that, Debbie. What causes the property of charge? Absolutely. What causes the characteristic of charge, the attribute of charge? What causes that? Exactly. And that's why I think our book that I threw away. That's why I think people are going to like it, even if it's wrong, even if this is completely wrong. It's because it says right there, the universe as moving mass. Everything in the universe is something real. It's a mass in movement. That's why I'm interested in writing this book. Because I, David D. Hilster, it's not because I want fame or fortune or anything, because it ain't going to happen. I want to finally have the ability to say, oh, here's something. It just happened to be coming from us. Here's something that will give physicality to everything, right or wrong. And actually have a natural philosophy reason, which I'm going to put in my book, as to why I think that it could actually describe everything, even if it isn't right. We could hack the universe wrong. That's why I call it a universe hack. Because if you make everything out of moving mass, you may be able to hack it and it'll work, but it may not be exactly the way that the universe is working. Okay, people are still staying around. It's like almost 2 hours. No one's going to, well, I guess people watch these things. I still think that's something, okay. I still think it has something to do with relatives, the force, see. What force would cause these particles to take a curved path like that? Gravity. If I send a, what am I doing that for? Oh, great. I'm going to start glitching here because I just brought up a program that's going to take the CPU cycles here. So, sorry about that. I'll get rid of it as soon as I can here. Anyways, the question is what force causes these particles to take a curved path? That's easy. Gravity does that. And if you look at gravity, let's say this is the way you think of it. If you have stars and those stars lined up, or even the planets, we have probes that go there. If I have a probe and I shoot it at one, it'll curve around another. So I'm sorry, I'm not seeing this because I have to get rid of, there we go. Okay, so like these are two things right here. So gravity causes curved lines all the time. Causes orbits, or it causes, you know, an orbit like this. It causes something to go through. If I shoot a probe out into the galaxy, it's going to curve a little bit more this way because it's closer to the sun, and then when it gets closer to another one, it'll go there, curved all over the place. Put nucleons. Now let's say there's a gravity down below. What is gravity? One of the models is it's just a bunch of particles going in all directions. Just imagine just ping pong balls going all directions all over the place. They're always just bouncing off. I mean, they're just going and they hit stuff, and that causes a pressure difference. Like I said, keeps them going like that. So yeah, curved, that's easy. I still think it has something to do with relative direction and or spin. If two objects, instance, have the same direction of axial spin in each other, they will push each other away. Okay, Debbie, let me tell you why that's not true. You have to have a medium there. Why? Why would they push each other away? They have to have some, if these two are spinning, that's why Yonel Denou is right. What happens is when he is spinning the stuff underwater, the stuff is spinning, but that's not what's causing the attraction, the repulsion. What causes attraction and repulsion is the medium which is spinning around it. So when you have spin, that's what's happening in some sense. Not spin, but that's how he does what I call the Denou effect. I sort of made that word up, Denou effect, because what's really happening with the underwater experiments is a little different than what I call the Denou effect, which is a more pure idea of that. So anyways, when you have these two things and they're spinning and they attract, they're not going to attract unless you have something around it, a medium around it. It ain't going to happen. If there was nothing around these two things and they're spinning, there's no air or anything, they're not going to attract or repulse by that. Careful. Hey, that's me, Dave. Not sure what that was for. I'm sorry. What's C bending do gravitational landing outside of chronostones all the time? We see bending due to gravitational. No. What you are saying is that you are repeating what mainstream says is happening. But when you look at it, what you are seeing is every object, when you look at this, and they're talking about bending, is near a sun. Suns have coronas that go out millions of miles. So if you are talking about an observational measurement like the NASA scientist who's a laser optical scientist who worked at NASA, who looked through telescopes, are you talking about people? You find me one. What you're talking about is that they use it. They use bending, but it's bending around suns. When they look at anything, oh, give you some exoplanets, right? Exoplanets are any planet that's outside our solar system. Oh, we find it because of relativity. No, we find it because it's really close. We have to look at the sun, and we have to see something go by it. We have to see the wobble it has. Everything that is very close to the sun. We're not measuring something that's hundreds of millions of miles away from the sun. We don't see it. We're starting to, because we can actually see planets because there's reflections off them. That's a different story. Careful. You're making an assumption that is not true. When people say, of course we do. No, they're not seeing stars outside. What they're seeing, they're using what they say is general relativity, but they're using the fact that light goes through mass and space, coronas of suns, coronas of big suns that go for a lot of millions and millions and millions and millions of miles. And then there is bending. Got to be careful. Lensing. Bending, lensing. Careful. I dare you to find it. You know, people make assumptions all the time. That's hard. You got to really separate when people say, but no, we know that for a fact. We use it all over the place. Every place they use it. It's very close in astronomical terms to a star. Oh, Lambda, do you believe in ether? I don't know if it's for me. Here's what I'm going to say. I will not tell you that ether doesn't exist. I will not say that. I am not in the firm conclusion that it doesn't exist. I believed before the particle model my father and I had that ether was the only thing out there that was viable. But I also say on top of that I never had a gut feeling that it was correct. I never had the aha moment that I had. I even read the book Universal Cycle Theory right here. This was a book that I read that was one of my 3 aha moments in my life scientifically. This was one of them. And it didn't have anything to do with ether. It had to do with infinity. That's what it had to do with. And it doesn't have to do with the cycle theory, which is Petz. I think it's his name, Petz. Pitts, I think it's called. Stephen Pitts. Love his work. Love this book. This book, when I read about neomechanics, I literally called up Glenn Borkert for an hour and told him, you guys made history with your, the infinity and neomechanics. You made history. You planted, but I didn't have that same feeling for any ether theory ever. And then when my father came along and described that light can be traveling waves of particles, that is, light is plurality of particles, it's not one particle, photon, no, photon doesn't make any sense. But that light can be waves of particles, brum, 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 lots of particles coming in, brum. Imagine that. Imagine you're driving along and you're hitting clouds of bugs. Well, you're hitting them in a frequency. They're all traveling together at the same speed. They're not a wave and a medium. So I am telling you, I don't want to say this because people will look at this part and then just kill me. That my intuition is the universal intuition. I have some universal capability that the aha moments point to me to real truths in science. That's for me. That's for me. I'm telling you my personal experience. I'm telling you being exposed to some of the greatest scientists outside the mainstream. And there are great science on top of great scientists. Hundreds of them. Thousands of really incredibly amazing thinkers. People who come up with theories, even like James Carter by himself, coming up with amazing stuff. He looked at, you know, the smoke rings. We have Yonel Denou looking at the same kinds of things. People who are brilliant are coming up with many of the same ideas. I have never had that for the ether theory. Whereas the particle, my dad's particle model for light, because you have two choices. You have particles, but you can't describe light with it, because if traveling particles like photons, you have a real hard problem. My dad tried spin as well, Debbie, with photons, and he said it didn't work. That's what led him to this other model. To Roger Ryden, I think, is another guy who said something very similar to what my dad said, but he never really made a model of it. But my gut feeling right now is it can be it, but I have not had that aha moment with it. I just haven't. Where's the particle model I have? Now, the particle model I have, I doubt every day. Every day. But the world can be digital? Absolutely. I really believe that the world's made out of moving mass. And it's going to be two types. Or it's going to be a combination of both, maybe. Maybe the particle model, that there are two types of waves. There are light waves and there's like laser type waves. And those waves can be this, you know, just, I don't know. I don't know the answer. But if I were to bet, I would bet more on the particle model side, even though I'm not convinced myself on either one. But the particle one, I believe, just has a lot fewer problems than ether. Ether is a light-oriented model. I said that in, I think I got that from a one of my other lectures, sorry, but one of my other live feeds. But then I think I made a point in my ether. I talk about ether. Just look up the dissident science ether. But look at it this way. I really came to this conclusion, it wasn't that long ago. Ether is a response by human beings in our minds looking at the universe to describe and give a physicality for light as a wave. That's what ether is. It's not something that someone made up for gravity. It's not something someone made up for electricity. It's not something someone made up for magnetic fields. It is specifically geared to one thing, light. And then after that, everybody tries to fit everything else into it. Then all of a sudden, oh, it's got to be everything now. Oh, I've got to get gravity out of that. How do I do that? How do I fit gravity into something that when I made real specific for light? I don't like that. With the particle model, we have a way to describe it all with nothing hard at all. Not like all the gravity explanations for ether, in my opinion, have been ad hoc, have been trying to fit something into it. Okay, not at Dave by this way. I'll see the link of bending light. How would your model define magnetism and electricity? I've actually came up with a simple explanation for that for our model. Gravity is particles, a field of similar particles, very similar particles, moving in all random directions, all in straight lines, all in random directions. It's just straight lines in all directions. And when you have that happening and you put objects in the middle of that and those objects hit some of them will pass through. But there is going to be some collisions because of that onto these. Then that creates more on this side because you have less, because this is blocking this and this is blocking this. It's called the shadowing effect. It come together. That's one thing. The other thing is electrical, magnetic, anything that's electromagnetic, all that stuff, there are flows. Then waves are just waves of particles. So electricity, electrical part of the universe, for those EU people, the way I would say it, it's flowing particles together. Gravity is the result of particles in random directions. Imagine that all the stars are spitting out gravitons or electrons or G1 particles, whatever you want to call them. They're all spitting out. They end up spitting out in all directions. So all those stars and all those things out in the universe are just spitting them out in all directions. So you get this general field of randomness. That's going to be gravity. Happens at our level, happens at another level, G2, G1, all that. And then electricity is actually the same particles, but they're all going and flowing together. Electricity is basically these particles flowing through metallic structures and metallic, using again gravity at the smaller level. So gravity, random direction of particles, electricity, magnetism, all that kind of stuff flowing together. And even in the repulsion, positive and negatives, when they're not flowing together, you have flows of particles here all together, woo, and then over here going in the opposite direction. If they go in opposite direction, they hit each other, spread chaos, they split things apart. The magnets themselves, for instance. They come together when they're flowing together. They come together. And those particles themselves will come together more and more, and that will bring everything together. But that's G2 level, which would be the strong nuclear force is the same as magnetic force, if you want to put it in terms with our model. But you're saying Stephen Crothers' book to release. Yep. I enjoy Stephen Crothers because it's sort of like the EU. They used to laugh at our saying Einstein's wrong. Now they talk about it all the time. They caught up with us. Little revenge there. Love Stephen Crothers, by the way. Love his work. He's one of our featured scientists on Science Woke. Talking about Stephen's book. Thanks. It could be still be a while then. I've been looking forward to as well. That sounds good. Theoretically, there are billions of comets, etc., in the orbit around the sun. Would that affect the path of light rays too? No, it doesn't affect light at all. If you're talking about common light, if you were to take it down a level and you're looking at nucleons being like suns, and in our model that's exactly the way we look at it, that the nucleus of an atom is like a sun, the electrons or the G1 particles, the particle that's light, light goes the speed of light. Gravity, according to when we do eclipses of the sun, total eclipse of the sun, gravity effects and light effects arrive at the same time. And a lot of mainstream science actually has said and measured. There have been a couple experiments that measure that gravity is the same as the speed of sun. So light is the speed of light is the speed of light. Gravity is the speed of light. Electrons go it's close to the speed of light. They're all the same particle. So what we say is that, in fact, they're going around they're going around and around the nucleons, and so you have like a cloud. I don't believe there's a 1-to-1 ratio. I don't think there's one G1 particle going around one nucleon, and we call that a hydrogen atom. So I really think that's what's happening, is there's a lot more than that. There's a capacity hold that they can hold, and that a nucleon can only hold so much. And that, that's the way we look at it, but that's our model. Right or wrong? In the context of supposed gravitational lensing. Yay! You said it right. There isn't gravitational lensing. I would say that we have light will go through coronas, and because we can measure that, we can depending on how much bent. But then again, the truth of the matter is, it depends on how thick that corona is. So the way I would say this would all be adjusted for gravitational lensing is that we have to say, okay, step back and say, okay, we know that it's not gravity that's bending it. What's bending it is mass in space. It's a corona. What's the mass of that corona? How does that relate to the mass of the sun or the star that we're looking at? And therefore use those kinds of things then to use for our calculations. But of course, we got all kinds of problems with calculations with cosmology. We always say, oh, we know exactly the distance of things. Well, we've got a lot of assumptions. So. All right, folks, it's dwindling down to the, I know people come in and out, but I am going to stop this because it's been over 2 hours. I do appreciate it, and please, none of you, my arguments trying to discuss whether you believe that charge is real or not, I'm not here to think you're stupid thinking that. I don't think that at all. I don't think any of your ideas, or if you subscribe to somebody or like someone's theory, that's wrong. Number one thing is you're here, you're listening, you're not going away. I'm not here to insult anybody. I just want to keep telling you. I'm going to keep firing at you until you get the idea. And that is, okay, I know I'm using charge. I like to use charge. I know that's an arbitrary thing, that there's really forces going on that causes orbits to happen, for polarity to happen. And someone may have a model that doesn't have charge. That's okay. I understand that. But you at least need to know that, and you need to say it. Okay? So, again, I'm not here to dump on anyone here. So. Need to head off now. Been really great discussion tonight, Dave, chat. Have a great evening, everybody. All right, folks. You know what I say. Keep critical. Keep thinking. I am David D. Hilster, your science therapist, trying to get you the promised land of being science woke. I appreciate everybody's patronage. If you have any questions, you want to contact me about anything, I'm going to be here hopefully almost every Friday night as much as I can, and I will do other videos. If you have something you want me to talk about, send me an email at david@dissidentscience.com. I'll be happy to take a look at it. And thank you so much. Keep critical. And don't believe anything I say. Investigate it yourself, folks. How many people say that? Not many. Ciao for now.